height of the solar cycle, the sun's magnetic poles flip. And on the Earth, that'd be like the North Pole and the South Pole swapping places basically every decade. And the sun transitions from being rather sluggish to being really active and stormy. Now, how we look at this is normally through sunspots. Sunspots are cooler regions on the sun caused by the concentration of magnetic field lines. They're around 2,500 times that of your refrigerator magnet. Sunspots are the visible component of the active regions, areas of intense and complex magnetic fields on the sun that are sources of the solar eruption. As the sun moves through this natural cycle, in which that activity rises and falls through these 11 years, sunspot numbers rise and fall too. NASA and NOAA track sunspots to determine and predict the progress of the solar cycle and ultimately solar activity. Solar minimum is characterized by the low number of sunspots, while solar maximum is marked by many sunspots. NASA is the nation's research arm, helping improving our understanding of near-Earth space and ultimately forecasting models. When the activity is directed towards Earth, a solar storm can create a major disturbance in the Earth's magnetic field, called a geomagnetic storm, like we experienced just a few days ago. That can produce effects such as radio blackouts, power outages, and beautiful aurora. We are able to see them down here in Virginia. They do not cause direct harm to anyone on Earth. However, our planet's magnetic field and atmosphere protect us from the worst of these storms. Strong solar flares, those that could power the United States for hundreds of thousands of years, rated M5 class or above, can have impacts on technology that depends on the Earth's ionosphere. So things that communications that travel through our electronically charged upper atmosphere, such as high-frequency radios used for navigation and GPS. When the bursts of light from those flares reach the Earth, it causes surges in electricity or flashes of light in the ionosphere, leading to those radio signal blackouts that can last for minutes or, in worst case, hours at a time. We anticipate additional solar and geomagnetic storms leading to opportunities to spot aurora over the next several months, as well as potential technology impacts. So since NASA's role is the research, basic, applied, and applications, NOAA is responsible for the monitoring and forecasting of the space weather. And with that, I'll turn this over to El Sayed, Director at NOAA.
Thank you, Kelly. As you've just heard, we are currently in the period of the 11-year solar cycle, known as solar maximum. During this time, we expect to see more sunspots, and therefore there's a higher chance of high-impact space weather occurring on any given day. Earlier this year, from May 9th to 11th, 2024, a barrage of large solar flares and coronal mass ejections, or CMEs, launched clouds of charged particles and magnetic fields toward Earth, creating the strongest solar storm to reach Earth in 2 decades, and possibly one of the strongest displays of auroras on record in the past 500 years. For decades, NOAA has observed space weather to produce warnings, alerts, and forecasts to protect the public and help stakeholders mitigate against the issues that space weather can cause. This includes ground-based communication systems, which are essential for emergency response, and communications and navigation, which pilots use to fly safely. The ever-growing fleet of satellites orbiting Earth is especially vulnerable. Even the GPS we use in our everyday lives is sensitive to space weather. Our need for observations and forecasts to protect our astronauts and assets in space is growing as the space commerce industry continues to expand. The GOES-19 satellite, which just launched in June of this year, had a new instrument for NOAA in its payload, the Compact Coronagraph, or CCOR-1. CCOR-1 is the first space-based operational coronagraph that the world has ever had, which means that CCOR-1 is specifically designed and flown with the specifications, dedicated 24/7 data delivery at low latency that space weather forecasters need for their operations. CCOR-1 will image the sun's outer atmosphere to detect and characterize the coronal mass ejections. CCOR will provide the equivalent imagery on the satellite to that of a total solar eclipse, like the one we just experienced in April, every 15 minutes. These are the measurements necessary for our long-term or 1 to 3 day forecasts of space weather events. Currently, CME imagery along the Sun-Earth line is provided by the LASCO coronagraph on board the European Space Agency NASA Solar and Heliospheric Observatory, or SOHO satellites. This satellite was launched in 1995 and is really a research satellite with research instrumentation. The CCOR-1 will provide critical early warning for impactful space weather, allowing us to see space weather leaving for the surface of the sun within 30 minutes of its occurrence. Today, that time lag for SOHO-LASCO data can be as great as 8 hours. Next year, NOAA is deploying a second CCOR, 1 million miles away from the Earth toward the sun, on its space weather follow-on L1 observatory that has additional instruments that act as an upstream buoy for incoming space weather hazards. These observations all go to the Space Weather Prediction Center, and I'll pass it on to Bill, who will talk about how they use them for forecasts.
Great, I'll say it. Thank you very much. So, well, greetings from the Space Weather Prediction Center out here in Boulder, Colorado. We're the official government source for space weather forecast watches and warnings. So just like a regular weather station, we're monitoring instead of just looking for hurricanes and tornadoes, we're watching the sun and space weather, but we're monitoring it 24 hours a day, 7 days a week. And as soon as we see something, we alert the public and all stakeholders as to the possible impacts of space weather. And my colleagues and I here at SWEPC, Space Weather Prediction Center, we observed that this solar cycle is a lower amplitude cycle. The cycle's period of solar maximum, which we talked about, began in early 2023, is expected to continue for at least 2025, but as Lisa said, continuing into the following year too. We first noticed the trend of slightly greater than expected sunspot activity in early 2023, so there's some adjustments that have to be made to the prediction of the solar maximum. It's been underway for about a year and a half now, that maximum period. And I will call out some activity and how it impacted us here in the Operations Center. In May of 2024, I'll say I just mentioned it, we had a series of large coronal mass ejections erupting off the sun that impacted technology here on Earth. And of course, from the media perspective, many people were very interested in the aurora, and indeed the aurora lit up the sky across the entire United States during that event in May. It was the largest we had seen since October of 2003. One of the key things, message I want to share with you is over the last decade, we have spent a lot of money, this nation, in preparation for a space weather event. So I think this was probably the most prepared we have been to successfully mitigate extreme space weather. A lot of people ask what happened. The answer I want to be able to give is nothing happened because we were ready. But a couple of things that I do want to share with you, that if these preparedness actions were not in place, the storm could have been much more consequential, and more work needs to be done because we know we can get much bigger storms that occurred so far this cycle, that occurred in May of this cycle. For example, the September 1859, known as the Carrington event, the February 1872, the May 1921, all big storms, several times bigger than occurred in May of this year. That is our concern. Are we ready for a storm of that magnitude? And these impactful space weather events continue. We just had one last week that again lit up the skies with the northern lights being visible, again all the way down into the southern states. And when we do have impacts, one interesting impact in the storm that occurred in May, we just learned some weeks ago that the precision agricultural industry in this nation had a $500 million impact because of the space weather event in May. These folks were relying on high-precision GPS to do their seed planting, their tilling, their irrigation. And on that particular weekend, 9 and 10 May, they could not do it because of the inaccuracy of the GPS because of space weather. So it's just a very tangible kind of impact from these space weather events. So why we're here today, so that we consider you, the media, our partners, to get this message out quickly and accurately. And I will say, from my experience this year, the May event and last week, that is happening much better than has ever happened before. So my appreciation to all you in the media for the great contributions you are doing to get that message out in that accurate fashion. I'll pass it on now to my colleague from NASA, Jamie Favors.
Thank you so much, Bill. So, good afternoon, everyone. Good morning, everyone. My name is Jamie Favors. I'm the director of NASA's Space Weather Program at NASA headquarters in D.C. So, as you kind of heard Kelly mention earlier, a lot of the work we do on the NASA side is really driven by science, the basic research we do. When it comes to something like space weather, it's very applied driven. We're really thinking deeply about those users, not only just a forecaster working in Bill's office, a SWPC in Boulder, but also those eventual end users too, like that, that farmer in a field in Ohio, like somebody operating a fleet of spacecraft in low Earth orbit, or even astronauts in deep space. Like, how do we make sure that ultimately, as a government, we work together to give them the best, most accurate forecast possible? And even beyond that, like, so we're here talking about solar cycle 25 today. How are we doing work today that prepares us for the next solar cycle, or the solar cycle beyond that, where we're reaching almost year 2050 and thinking about probably tens of thousands of spacecraft in low Earth orbit and astronauts sustainably on the moon and maybe our first mission to Mars? How do we prepare ourselves today for that eventual reality, protecting society, multiple decades out in front of us? And really, that's driven by those user needs, doing that science, make sure we're developing our models with that basic scientific understanding, bleeding into those models to give us the best, most accurate prediction capable out there for the public to be able to use, not only for solar cycle prediction, but for the day-to-day space weather that we experience. That eventually goes onto the table for one of those forecasters out at NOAA or Department of Defense or any of our international partners leading in there. So a lot of this work on the NASA side to be able to answer those scientific questions, we have to collect the data. We're actually in a pretty exciting time now that within NASA Heliophysics Division at headquarters, we have multiple missions in front of us over the next few months and the next couple of years launching. So it's a very exciting time for us. Just a few of the small sample of upcoming missions. We have a mission called Escapade, which will actually be 2 spacecraft launching early next year, heading towards Mars. So we've been talking quite a bit about the May 2024 space weather event here at Earth. And actually just 10 days after we had our large event here at Earth, we measured and observed the largest solar energetic particle event we've ever measured at Mars with a couple of different instruments. One, the RAD instrument that measures its high energy particles at the surface. It's an instrument that's on one of the rovers, also with the MAVEN spacecraft in orbit around Mars. So measuring that environment. So not only do we see that big event here at Earth, but it happens anywhere across the solar system. So preparing us to be able to make those measurements and understand the science, missions like Escapade can really help us with that. And as you mentioned, and we heard earlier from El Sayed, with their SWPO mission, we'll be launching with our mission, IMAP, really driven by science questions that will also be providing some really critical data, hopefully real time, to be supporting a lot of the operational work that we do within space weather. And as always, one of our big missions right now, the Parker Solar Probe, actually on Christmas Eve this year, coming up in December, later this calendar year, we'll start making its closest approach to the sun and actually enter into that and actually closing out our heliophysics big year, which has been big in more ways than we realized we were getting into at the start of it. So it's been a really exciting last year or two, a really exciting couple years in front of us. And just a tag, too, to also think about, you don't just have to have PhDs to be involved in the work that we get to do in space weather. It's a really exciting time, and anybody can participate through a lot of our citizen science work. I'll call out one in particular called Aurora Source. So just like last week or the event back in May, you with an app can start collecting information at the citizen level, feeding into the NASA network, into the NOAA network, that really gives us pretty critical data about observations that really drive a lot of the scientific work we do. So, make sure you're participating and always either amplifying the message, collecting data, or just being that advocate of the really important work that we get to do for society within space weather. And with that, I think I get to hand it back over to Sarah.
Thanks, Jamie, and thank you, everyone. So we are now going to move into the Q&A portion. So just a reminder for the reporters that are on the phone, you can press *1 to get into the queue to ask a question. And when you do ask your question, just please state your name and affiliation. And if you are directing your question to someone specific, you can go ahead and address it to them as well. So I will hand it over to our operator, Christy, to start the Q&A.
Thank you. At this time, the first party will be Andrea Leinfelder. Your line is open.
Hi. I believe this question is for Kelly. During this solar cycle, have more auroras been visible in the southern part of the U.S. than normal, or is it, typical to see them this far south or in solar maximum? Also, could there be opportunities in the coming months to see more in the southern portions of the country? Thank you.
Thank you, Andrea, for your question. There has been more sightings in the south this time around, just due to the strength of the solar cycle. There is still the possibility of more aurora to come. Lisa did mention in the declining phase, we do tend to still get very large storms. So there's the possibility that we can still kind of go this far south. Again, this is not as big as that Carrington event like Bill mentioned that went all the way down to Hawaii, but we still could possibly get some good shows in the next few months.
Thank you. Our next question will come from Adith Ramakrishna of the Associated Press. Your line is open.
Hi. My question is about, I guess, preparations moving forward to mitigate communication problems with the coming auroras. I guess, what are some of the possible impacts that we could see over the coming months, and would any of that impact some of the disaster relief that's going on in the southern parts of the U.S.?
Bill, do you want to take that?
Yeah, I'll take that. So there's different types of space weather can impact different types of communications. So it's rather complicated, unfortunately. Where we see the aurora, when we look up north and we see that aurora, generally in that location, so point further north is where we have biggest problems with communications. And again, it depends on the kind of communications. But when we do get these big geomagnetic storms, like last week, it can interfere with a layer of the atmosphere above us we call the ionosphere, and we bounce signals from the ground off the ionosphere, and signals coming from satellites have to go through the ionosphere to receivers on the ground. So during the big storms, it can be interfered with, and we see it all the time. Last week and back in May, for example, high-frequency communications with aircraft were significantly impacted, mostly, again, at the higher latitudes. But last week, we were advising FEMA and other emergency responders that, yes, be ready, be prepared, because the communications you are relying on, and indeed GPS, those signals may be degraded during a response, those important response and recovery efforts following those hurricanes. So we got the information out. It's very difficult to get feedback whether they did experience communication problems. But key for us is to get that information into their hands so they know what's causing problems when they have it, and they know the alternate processes they turn to essentially complete their mission.
Thank you. Our next question comes from Meredith Garofalo of Space.com. Your line is open.
Thanks. Hi, everybody. Great so far. And this is for whoever feels like they want to answer it. With what we've seen with the performance of the solar cycle, are there any other trends of activity that you are concerned about? And also specifically with risks to astronauts, has that increased for solar cycle 25? We have the Artemis 2 and Artemis 3 missions coming up in 2025 and 2026. Are there any concerns for our astronauts that are going or astronauts at the International Space Station at this point?
Jamie, can you take that?
Sure, I can start on the second part of the question first, and then maybe Bill with Swipsy can jump in on part of that as well. So, so you're right. As we're looking forward to Artemis 2 next year and then Artemis 3 the year after that, what is unique there compared to what we do on the International Space Station today is that those astronauts will actually be outside of the magnetosphere, which is what protects us from most of those harmful effects from the sun. So those astronauts will literally be in deep space and protected only by the spacecraft they're in. So those forecasts provided by Swipsy are ever more critical for the decision-making and the safety of those astronauts that go on at that point. And even more so as we start to look way downstream and think about Mars at that point, and how we set up those crews to be fully safe the entire trip they make out to Mars. But Bill, was there anything you wanted to add in on the astronaut and crew safety part?
Well, I was going to say, Meredith also asked about the trend, so I just wanted to comment on that. One of the unusual things we've seen this cycle is kind of an absence or the lack of big energetic particle storms. Or in NOAA, we use the S-scale solar radiation storms. And I would have emphasized it more prior to last week, but last week we finally had that S3 level storming. But in the May activity, when we had the G5 storm and the aurora lit up the skies across the country, it was accompanied by a very low energy particle event, which was quite surprising. So when we look back at the last E5 storm, which occurred in October of 2003, there was significant solar radiation storms that occurred then. And those types of radiation storms can affect the astronauts. In fact, we took action in 2003 to protect the astronauts, affect satellites, and even our airlines flying high latitudes and polar routes will start rerouting flights when they hit that S3 level. But just that absence of energetic particles, there's been nothing really written or discussed, studied about it yet. There's a long time to go yet in this cycle before we make any conclusions, obviously. But interesting that there's been a less energetic particle events than we've seen in last cycle.
Do you also think it could cause an internet apocalypse? I mean, we see people on social media so much just blowing up about this, and it feels like every event that we have, it gets worse.
No, I think I will say this. One of the things we are doing, and the Department of Homeland Security are behind this effort, and that is to fund a benchmark initiative where we're going to work with our scientists around the world, indeed, to establish how big is big. Because when you ask that question, what apocalyptic? How big can it be? We really just don't know how large it can be. So we're going to embark on an effort to understand how big can a magnetic storm be? How big can a radiation storm be? And that's going to help us mitigate and prepare for such event. But I mean, obviously, we've been watching the sun now for several hundred years from a sunspot perspective, but studying it largely for the last 50 years or so. I don't think we're not expecting anything apocalyptic, but I do think we can see space weather events that are certainly a lot larger than we have seen, and that could cause some problems with our power grid, satellites, communication systems, GPS, and other technologies that we rely on for everything we do today.
Great. Thanks, everybody.
Thank you. As a reminder, if you would like to ask a question, please press star 1 on your phone. Our next question will come from Megan Bartles of Scientific American. Ma'am, your line is open.
Hi there. Can you hear me okay?
Yes, you sound good.
Perfect. Thanks so much for making the time. I have a question for possibly a combination of Lisa and Bill, possibly someone else. Could you talk a little bit more about what we can expect in terms of non-polar northern lights in the coming months or even years, and especially as we transition from the maximum phase into the descending phase? Can you talk a little bit about what's actually happening on the sun to keep that activity going, even as sunspot activity starts to die down? Thanks.
Yeah, sure thing. I can weigh in on this. So, the solar cycle waxes and wanes. We're at that maximum period. The specifics about how space weather events occur are very complicated, and it depends on how the magnetic field on the surface of the sun is interacting. When there is a strong release of energy, and that energy happens to be directed towards the Earth, that's what's going to create these very large geomagnetic storms that will cause the aurora, that will cause all these disruptions to our infrastructure. And so we can expect that, during the declining phase, we will probably still see some very large geomagnetic storms. I don't know, can't really say whether or not they'll be larger than what we've seen so far or not. But when those storms happen, we can expect to see aurora dipping down to the lower latitudes, as we've seen with these two large storms that we've experienced already this year. But I don't think that's anything out of the norm, anything unusual.
And I'll just add to that. We looked at the historical records and see the average of G4 occurrences or G5 occurrences over a solar cycle. And those G5 storms, like we had in May, very rare. We did not have the last one. We had October 2003, and then May of this year. So it's a 20-year. But we almost had one last week. But the G4 storms When we get those, we've had about a handful or so this cycle so far. We typically get several dozen at that level. So as Lisa said, there's going to be more geomagnetic storms at that G4 level on a scale of 1 to 5. So 4 is severe, and typically with G4 storms, we will see the aurora extend into Northern California across that line of latitude to the Carolinas. So more to come.
Thank you.
Thank you. Our next question comes from Jonathan O'Callaghan of the BBC. Your line is open.
Hey, thanks for doing the conference. I just want to clarify, how do you actually know the sun is at solar maximum at the moment? Is there a strict definition that has caused you to kind of call this conference? Like, has it reached some sort of threshold that has made that definition a reality?
Yeah, I can answer that. So the determination of the maximum of solar cycle, as I mentioned earlier, we can't really do that with precision or certainty until well after it's occurred, because we have to smooth that monthly sunspot data and to be able to determine where that peak is. That being said, there is a general shape to the solar cycle that it typically follows, and if we look at the image showing the solar cycle progression so far, you'll see that instead of the rapid increase upward that we had during from 2020 to 2022-ish, it started to flatten out when you look at that smooth sunspot number. And so it's been relatively flat or flatter over the last couple of years. And that's well in line with how we would expect the solar cycle to progress. And so it's by looking at the shape of that cycle, how it's progressed so far, and how we know that solar cycle progresses from our observations of the last 25 solar cycles, that we can really say that we're at the maximum phase now. But again, determining the exact peak of the cycle, we won't be able to do probably for another year or so.
Thank you. Our next question comes from Meredith Garofalo of Space.com. Your line is open.
Hi, thanks for entertaining me again for another question. Everyone who I've talked to knows I love this stuff too. So my question goes with kind of the takeaways from where we're at. You know, with the solar cycle heating up, I mean, we're in this phase now. We've seen more activity. It's becoming more talked about across the country. Are there any new threats that you are concerned about? I mean, we have so many technological advances that have moved forward versus where we were in the last solar cycle. Are you worried, or should anyone be worried moving forward into this possibility of the next couple of years with the max? Or is it kind of you're learning from these events, and now after every event you can give more advanced warning, just like scientists do when it comes to tornado and hurricane watches and warnings?
Hi, Meredith. It's Bill here. I'll just make the first comment on that. A key to this question, the answer to this question, is preparedness. If we don't issue any alerts and warnings and nobody knows this is coming, then we're going to have some problems. As simple as that, and that's no different than regular weather forecasting. In 1900, a hurricane hit Galveston and killed 8,000 people because there was no warning. That doesn't happen today because we get those warnings out in time and people can take action. Same thing with space weather. If we get the warnings out, the operators of key critical infrastructure, most importantly the electric power grid, get the information and take action. And just last week we gave them 24 hours notice. We have a way to communicate with all 3,000 companies that provide power generation and transmission for this nation. And indeed Canada, we get that information to them. They take the actions to protect the grid, and nothing happens. So that is really so important, is that we take those actions. And there's new technologies evolving all the time, autonomous vehicles, the fiber cabling, all these different things that we're working closely with various groups, private sector and government, to assess their vulnerability to space weather. As we determine those vulnerabilities, then we work on the mitigation strategies And key to the mitigation strategies is either an engineering solution or warnings ahead of time so they can prepare and take action.
I'll just add to that, absolutely preparedness is key. But as Jamie alluded to earlier, we are becoming a spacefaring race. We're putting more and more assets out into space and moving to other places in our solar system. And so as we increase our assets out in space, as we venture to the moon, as we venture to Mars, and anywhere else that we might want to send humans in the future, as that increases, we're going to need to increase our ability to understand space weather, not just here at Earth, but across the entire solar system.
Was that Lisa or Kelly, just to confirm?
Lisa.
Thank you, Lisa.
Yep.
Thank you, Bill.
So it looks like those are all the questions we have in the queue right now. So I'll give it another minute or so. Just a reminder, you can dial *1 to get into the question queue. We do have about 20 minutes left for questions, so we can definitely take a few more if you guys have them. While I give you guys a couple minutes to do that, just a couple of notes. So a replay of this call will be available on YouTube. If you're listening on YouTube, it's the same link that you're on right now. Otherwise, you can go to nasa.gov/live and grab that link. It will also be available through this teleconference system by dialing 800-925-0258, and that replay will be available for 30 days. And then you will also be able to get more information about everything we've discussed here at nasa.gov/sun. We have an article about this announcement and the progression of the solar cycle, as well as some images that go along with this telecon. And then you can also get more information from NOAA's Space Weather Prediction Center about all the latest space weather alerts at spaceweather.gov. And it looks like I did buy enough time, so we have a couple more questions in the queue. So I will pass it back to Christy to take those questions.
Thank you. Megan Bartles of Scientific American, your line is open.
Hey there. Thanks for opening it to more questions. I wanted to build on what just came up in terms of space weather in locations other than Earth and the Moon and potentially Mars. Could you talk a little bit more about sort of what we know at this point, what some of the big questions are? Is there like a whole bunch of space weather that's going off in directions that's not pointed to Earth and Mars, and do we know anything about that stuff? Thanks.
Yeah, certainly. So, the sun is a sphere, and it emits these space weather events all around the sun, and so not just directed at Earth, but throughout the heliosphere. And so we need to understand space weather events. We need to be able to take measurements across the solar system. So, for instance, there are times when the Mars is perhaps on the other side of the sun from Earth, and so we want to know information about the storms that are directed away from the Earth, or that might be directed in that direction. And so, while we have models that help us understand and predict what might occur there, we don't necessarily have as much data as we might like to have in the future to be able to view the sun at 360 degrees. And so I think, moving into the future, those are the kinds of things where we'll want to improve our capabilities and be able to see the entire sun so that we can see storms regardless of which direction they are moving from the sun.
Yeah, and I'll just add too, maybe that, along with being able to observe the sun from any angle is important for the solar system. It's also just that unique environment that is at every planet or even some of the moons as well. And that kind of gets us a little bit to what Bill was talking about, of an impact-driven science. You have to understand, the magnetosphere at Mars is very different than it is here at Earth, and understanding scientifically how it's different and how that may, react with the space weather that's coming towards Mars ultimately leads us to be able to do a lot of the space weather activity and the forecasting and that capability. And that story just carries across all of the solar system.
Just one thing to add to from the operations perspective, risk management. We're always trying to figure out how frequent these events are, these major events. So we have this people, 60 people on fire in the sky, the sun, about 50-degree window or so, when the eruptions occur inside that 50-degree window, they impact us here on Earth kind of head on. Big events occur other times, and we had an event in 2012 that occurred on the far side of the sun. And fortunately, NASA has spacecraft out there that could measure that coronal mass ejection associated with that eruption, and we were able to determine that was a century-class event. So we're able to share with folks, hey, we got lucky. Had that event occurred 8 or 9 days earlier, that sunspot group that produced that eruption would have been facing Earth. So understanding what's happening on the sun all the time just helps us get that kind of broad perspective we need to understand as we prepare for these big events.
Thank you.
Our next question comes from Andrea Leinfelder of the Houston Chronicle. Your line is open.
Hi, thank you for the second question. I just want to confirm, last week was a G4. Was it like a strong G4, almost G5? And also, were May and October the only times this year that the northern lights have been visible in the mid-latitudes? Thank you.
So yes, the event that occurred last week, I was quite surprised that we did not reach the G5 level. So it was absolutely a strong G4. We have a spacecraft, 2 spacecraft out at the Lagrangian point, 1 million miles out in space, that Alfred mentioned, and the measurements we were seeing on that spacecraft suggested to me it would be a G5 type storm. So it was very close to that, but didn't quite reach it. There have been some other events. It was May and October, definitely the 2 biggest storms this year, but we did have another G4, and I think it was in June. And last year we had the April and May, or was it the March and April G4 storms. Every time we see those G4 storms, we are going to see aurora down into certainly the mid-latitude states.
Thank you. And I'm sorry, can I get your name one more time?
It's Bill Murtaugh from Space Weather Center in Boulder.
Thank you.
Thank you. Our next question comes from Morgan McFall Johnson of Business Insider. Your line is open.
Hi, can you hear me?
Yes.
Hey, I'm just hoping to nail down the timeline here. So you're saying that we're 2 years into solar maximum at this point. There's potentially another year, maybe even 2, left of solar maximum, but you're also saying the next few months or the next several months for aurora viewing opportunities. I guess I'm just curious if there's a particular window of time or estimated window of time for the ending of the big aurora events, and then also how long into the declining phase can we expect to continue seeing potentially big events? How many years more of that do we have? Thank you.
Yeah, absolutely. So, when we talk about, the last 2 years and the next year, maybe year and a half, that just means that we're at the solar maximum period. And what that means is that there's more sunspots emerging, the magnetic field has more chances to interact and increase the probability of having a significant geomagnetic storm. That being said, significant geomagnetic storms can occur in any phase of the cycle. Again, they can occur in the declining phase even as we're getting very close to solar cycle minimum, just depending on how those magnetic fields are interacting on the surface of the sun. So there's potential really at any phase of the cycle, but the frequency increases when you're at the solar maximum phase. And so we expect to be in that maximum phase for at least the next 6 months to a year, maybe even a little bit longer. And so definitely a higher probability of seeing those intense geomagnetic storms during that phase. But they can continue, and we might experience some even later in the cycle.
And just as a couple of examples, the Halloween storms in 2003 occurred 3.5 years after solar maximum, and the largest radiation storm we had in that cycle occurred in January of 2005, which was 5 years after solar maximum. So absolutely correct. We're seeing the peak now, but we could get them at any time.
Just Kelly, just adding that because it's winter is in the next few months, or as we get more and more darkness, it's just also easier to see them, right? Had the event last week happened this summer, we wouldn't have seen it at 7 o'clock in DC. But because it's fall towards winter, we're able to see more basically nighttime skies and able to see the aurora a little bit better.
And just for the record, that was Lisa and then Bill and then Kelly answering that question.
Correct.
Great, thank you.
Thank you. Our next question comes from Kasha Patel of the Washington Post. Your line is open.
Hi, thank you. I saw that NOAA is looking at reclassifying how we categorize these storms. Do you know when that will be taking place, when that will be coming out, and what kind of changes you're looking to do?
Hi, Kasha. Yes, Bill here. That's the update. I assume you're talking about the update to the NOAA space weather scales. So it's a okay, good. It's a 2-year initiative. This whole first year, it essentially concluded last week when we were in D.C. holding an event at the Brazilian embassy. We were calling it the Americas event, where we coordinated with our colleagues in Latin America as well as Canada and stakeholders here in the U.S., getting everybody's input to what the scales should look like. And this was preceded by events in Australia and Europe and in Korea, because these scales have been adopted by nations around the world. So we think it's very important that we coordinate with our partners around the world and, of course, with these stakeholders across the United States. So we've worked with the power grid, satellite companies, airlines, etc., all providing this input. So this is kind of the phase one of phase two. Phase two is essentially the report that will be provided to us. And us is not just the NOAA Space Weather Prediction Center, but the larger federal government. We have an entity called the SWARM, Space Weather Operations Research and Mitigation Subcommittee at the White House, will receive this report with the proposals for some changes. I could see, Kasha, some of the changes being that could be implemented quickly, and others that will be much longer time frame over several years. For example, when we use the term solar flare radio blackout, people are confused that when we say radio blackout, that all types of radio communications are being impacted, when in reality, it's just a certain type or a couple of types of communication systems are impacted. Maybe that's a change we could make pretty quickly. So that's basically it. The report's going to come out, and we're going to look at the recommendations or the options going forward, and everything that any changes that we make as National Weather Service NOAA rules is that we coordinate with the public, the nation, the citizens on these changes, letting them know what's happening, and we'll certainly be coordinating with our colleagues in the media for any substantial changes, so everybody is well aware of what's happening. Does that help?
Yeah, so it's not like you're going to be expanding to like G6 or breaking that down in more on the geomagnetic scale. It'll probably be more of like the radiation blackouts.
All three scales have issues, and you just nailed one of them, and that is that G5 storm that occurred in May. Is a good-sized storm, but I've already said the 1859, the 1872, the 1921 storms. What were they category-wise? They were also G5s, but with much greater strength and much greater potential for consequences. And that is getting lost a little bit. We refer to it as that saturation on the geomagnetic, at the high end of the geomagnetic storm scale. So that, too, is being addressed.
Gotcha. Thank you.
All right, that looks like all the questions we have in the queue right now. I'll give it one last call. If you do have a question, please press *1. Otherwise, we will wrap up here in just a moment. We only have a few minutes left. So thank you all so much for joining and for your time today. I am not seeing any other questions in the queue. Just going to give it a few more minutes. And just a reminder, you can find more information about this at nasa.gov/sun or at spaceweather.gov for all the latest space weather alerts and forecasts. Just waiting a few more seconds to see if there are any last questions. Oh, I do see one.
Morgan McFall Johnson of Business Insider, your line is open.
Hey, thanks for the second question. I'm just wondering if you have any final thoughts to share with lay people about just how special this moment is and how special this final year of solar maximum is.
This is Kelly, and I am definitely excited about this because it's our chance that basically we've had something from the sun 93 million miles away come and interact with us, and just that awe that if you've seen the aurora that you have of the beauty that this causes, and also thinking about how our technology is so affected by this and how we're really all connected. So for me, it's a time to think about all of those things, to think about the science we still know, and to think about, how beautiful it is on Earth, and that we've as a human race have, observed this for thousands of years, and really wake up in awe and feel that deep connection to the sun, as well as, the future, looking towards the future. Imagine what our, nth grandchildren will see as they're on Mars and seeing, or Jupiter, and seeing the aurora. So really, it's a time of to just take a second and think about the interesting connection to the sun.
Thank you.
This is Osaid. I want to add to that from an operations standpoint. We've been working very hard for the last several years to make sure that our observing infrastructure is ready for solar maximum and the declining phase of the solar cycle, when the events really pick up, the dangerous space weather storms pick up. And so with the GOES 19 launch and then the SWIFT 1 launch, we'll essentially add resilience to the system to sort of replace these aging assets. And so I'm very excited that we can, with the Space Weather Prediction Center and the alerts and warnings and forecasts, that we hopefully have the observing structure in place, that aurora is what we can focus on rather than than any adverse effects.
From the Space Weather Prediction Center, it's always a challenge for us because everyone across the nation loves the aurora borealis on everyone's bucket list. So captivating. The bigger the storm, the more visible the aurora, the further south it's visible. But at the same time, we can't be hoping for these big displays because with them comes the threat to our critical infrastructure. So we always have to be careful with what we wish for. But inevitably, as we've already said, the day is young. The cycle will produce many more geomagnetic storms that will result in aurora being visible pretty far south. We just hope it's not too strong. So, thanks.
This is Lisa. I'll add one more comment. I think as a scientist, the solar cycle on average lasts about 11 years, and a lot can change in that 11 years. The technology that we have here is so much greater than it was a decade ago or 2 decades ago. And so it really gives us a unique opportunity to view the sun in this special phase, in this maximum phase, and develop a much better understanding. Our data that's coming into us from all of these assets that NASA and NOAA have put up there is just top notch. It's better than it's ever been before. And so it gives us a unique opportunity to investigate and discover more about the sun. And so I think that's a really special thing as well.
Yeah, I guess I will only add, echoing kind of where Kelly started the conversation, that I think there's magical moments in science sometimes that just connect you with who you are and the people around you. I just last week happened to be in Minnesota with the solar event going on, and found myself in some far off dark field and realized I had a dozen other cars around me of people I'd never met before, and having that connection and very tangible ways to observe, scientific things going on, it just kind of stirs curiosity in the older people, but also hopefully in that next generation that may spark future space weather people, but maybe just some kid to be interested in science and engineering in a place that they hadn't thought about before. And really that's ultimately who is going to get us into really exciting things into the future as well. So that's times where science can connect us to who we are and the future generation on where we'll go is pretty exciting.
Thank you. Our next question comes from Jonathan O'Callaghan of the BBC. Your line is open.
Hey, sorry, I just have one more question. Just regarding the aurora and kind of the visibility, it feels like we're seeing a lot of news stories, a lot of pictures at the moment of the aurora. Do you think that's a function of kind of smartphone technology being better, people being more easily able to kind of image the aurora in the sky? I mean, these maximums, they're not different to the ones 11 years ago or 20 years ago, 30 years ago. Would you say the increase in technology has made them more accessible?
Yeah, this is Kelly. Definitely, the fact that we have computers in our pockets and everyone basically most people have them and able to take these pictures. It is a way to share, a way to connect, and that's why you see so many more pictures of it, right? Last solar cycle there was just less emphasis on those things, and 2 solar cycles ago there was definitely less images and availability of taking a camera picture. You didn't have to go and develop it and, only develop a roll of 12 or 24. You can take a lot. And so, yes, the increase in technology has helped us connect in this way.
Great, thank you.
All right, we are all out of time, so we will wrap it up there. Thank you again all so much for your time and your interest in this. Again, you can visit nasa.gov/sun and spaceweather.gov for more on everything that we've talked about today. And definitely keep an eye on those 2 spaces over the next months and years as we see more events from solar maximum and more research and more observations. But other than that, we are done here. Thank you so much.
Thank you. This does conclude today's conference. You may disconnect at this time. Thank you and have a good day. Speakers, one moment.